Alright, in this section, 2.2 of Unit 1, we'll talk about average speed and velocity. And with average speed, it's basically just the distance divided by the elapsed time. The average speed can never be negative. That's because your distance is always going to be a positive number. You're just traveling. It doesn't matter which direction you're traveling. You're traveling over a certain distance. That's going to remain positive. So that means your average speed will always remain positive. In this situation, we have average speed equals distance over time, and then we have average velocity. Average velocity is displacement divided by time. Now remember the difference between distance and displacement. Distance is the entire distance you traveled no matter where you end up at. You could go around a track and end up back at the starting line where you started at, like a horse race where they go around an oval track. You'll end up right back at the starting line, and that might also be the finish line, and you've traveled a distance around that track. With displacement, however, displacement is where you end up at. So it's not counting the total trip, it's just counting where you started to where you end up. So if you start at a certain point and go around the racetrack and end at the finish line, which is also the starting line, right back at that same point, your displacement is 0. So displacement excuse me, displacement is not like distance. Displacement is strictly how far away you are from where you began. So displacement is the starting final position minus your initial position. So final position minus initial position is displacement. And of course the change in time is final time minus initial time. And sometimes in these word problems you'll see that they'll give you the time. You don't have to really figure time too often. So let's just take a look at what we have for examples. Okay, and the first example is a kingfisher is a bird that catches fish by plunging into water from a height of several meters. If a kingfisher dives from a height of 7 meters with an average speed of 4 meters per second, how long does it take to reach the water? Well, what we're going to do is we're going to go back and use those two formulas we just learned about. And this one will be the formula we need for this problem. Average speed equals distance over time. So we look at our problem and we say, okay, there's a height of 7 meters the kingfisher dives from, and his average speed is 4 meters per second. So let's go back over here and write our stuff in. We have average speed equals distance over time. Now, it's wanting to know the time. In the problem it says, how long does it take for the bird to reach the water? So we know we're looking for the time it takes. So if we go back over here, and we need to rearrange this, algebraically rearrange this equation to solve for time. Now please don't say just divide both sides by distance and get average speed divided by distance equals time. That is so wrong. You can never divide by the numerator. You can only multiply by the denominator to break up a fraction. So we have to multiply by time on both sides, and that would give us time times average speed equals distance. Then to get time by itself, we would divide by average speed to get rid of it. So rearranging this would look like this. Time equals distance over the average speed. If these trip you up, go back and look at my packet. Your summer work had all this in it with rearranging things algebraically. Make sure you are proficient at rearranging equations algebraically, because not too often do you just get this equation and then the word problem sets it up to where you're going to solve for average speed every time. You'll be solving for many different variables. You need to know how to solve for each variable independently. Okay, so time equals distance over average speed. So let's fill in what we know about these. Time equals distance. Our distance was 7 meters. Our average speed was 4 point, let's see. What did they have? 4.0 or 0, 0, 0, 0. So 4.00 meters per second. Now if we use our calculator, (7 divided by 4) equals 1.75. 1.75, and meters will cancel, and we'll be left with seconds, which is fantastic because we're solving for time. Time is in seconds. So 1.75 seconds. And if you look, we have 1, 2 significant figures here, 1, 2, 3 significant figures here. So we're going to answer this in 2 significant figures. So this will equal 1.8 seconds. And that is how long it takes the kingfisher to dive from 7 meters high at an average speed of 4 meters per second. Okay, our second example. It says you drive 4 miles at 30 miles per hour and then another 4 miles at 50 miles per hour. Is your average speed for the 8-mile trip greater than 40 miles per hour, equal to 40 miles per hour, or less than 40 miles per hour? Now, I'll warn you, it's easy to look at this problem and say, okay, 4 miles, right here you say 4 miles at 30 miles per hour, 4 miles at 50 miles per hour. Well, right in the middle of 30 miles per hour and 50 miles per hour is 40 miles per hour. That's got to be the average, right? Let's look at the problem and check it out and see if that's right. Okay, so remember, our average speed is distance over time, and for this problem, what we were given your distance of 4 miles and your average speed of 30 miles per hour. So once again, we don't have time for either one, so we must solve for time for both of these segments of the trip and then combine that for your total time, and then we can plug that into the final equation. So we're looking for time. So once again, our average speed equals distance over time. We will need to rearrange that algebraically to get time equals distance over average speed. So if we do that for both of our problems, let me save a little time. Okay, I've gone ahead and done the solve for the time on each part of the trip. Part 1 of the trip, we traveled 4 miles with a speed of 30 miles per hour, and that took 0.133 hours. I kept 3 significant figures. Then I came over here, part 2 of the trip, 4 miles, traveling at an average speed of 50 miles per hour, and that is 0.0800 hours. So our total time of this trip was 0.213 hours. Now that we have our total time, we can go ahead and solve for our average speed. And just remember, our average speed is nothing more than distance over time. So in these 2 different parts of the trip, we traveled 4 miles on each part. That means total distance, let's see, average speed equals our total distance was 8.00 miles. And our total time is 0.213 hours. And look, you can see how the units are going to work out. You'll know sometimes when you're setting up a problem properly, if you look at your units, average speed is going to be in miles per hour. So when we have miles on top, hours on the bottom, we know we're setting it up correctly. So let's see what this is. 8 divided by 0.213 is 37.558, so 37.6. So our final answer is 37.6 miles per hour. And if you can keep the figures in your calculator, if you are very good at calculating and not having to write it out step by step and can calculate all the way to the end, you'd get 37.5 miles per hour, because this answer right here was 0.133333333 continuing 3. This was 0.08. So if you had 0.08 plus 0.1333333 several 3's, you'd have 0.2133 continuing 3. And under here you'd have that, which would give you 37.5 miles per hour. But I don't mind if you round to the proper number of significant figures at the end of each step. That's fine. You'll come up with maybe a decimal place different. And on a test, if it's A, B, C, D, and you came up with 37.6, but you see 37.5, you'll know that somewhere along the way it was a rounding issue with decimals. So in case you came up with 37.5 and kept the decimals in your calculator, don't worry about it. That's fine. So 37.6 miles per hour would be our final answer for this problem, or 37.5 miles per hour. But what I wanted you to see was You can't just say 30 miles per hour for 4 miles, 50 miles per hour for 4 miles. Okay, that's an average of 40 miles per hour for the 8 miles, because it's not equal to 40 miles per hour. It's actually less than. So the answer for this one would be C. Okay, and our last problem is an athlete sprints 50 meters in 8.00 seconds, stops, and then walks slowly back to the starting line in 40.0 seconds. If the sprint direction is taken to be positive, what are the average sprint velocity, the average walking velocity, the average velocity for the complete round trip, and the average speed for the complete round trip? Now, let's look over here. Kind of rewritten the problem on the top of my sheet, at least the facts that we need. Now, the athlete sprints 50 meters in 8.0 seconds, and they said take that as the positive direction. So I put a positive below here, which means when he walks back to the starting line in 40 seconds, he's walking in the negative direction. And it's just like an integer line. As you go to the right, the numbers are positive. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you start at 0 and go to the left, it's negative 1, negative 2, negative 3, negative 4. So we just have to imagine this sprinter is running in our scenario in our head, our sprinter is running to the right, and that would be the positive direction. So remember, we're solving for velocity on this first one. It says, what is the average velocity of the sprint? So if you look at velocity, it's velocity average equals change in displacement. Displacement over time is the change of position over time, which is the displacement. So 50 meters is where he ended up, because remember, on that last formula you learned, it's final position minus initial position. Initially, he was at the 0 meter mark. His final position, where he stopped, was 50 meters down the track. So final position, 50 meters, minus initial position, 0 meters, divided by the total time of his run, which was 8 seconds, 50 meters, divided by 8 seconds, and you come up with 6.25 meters per second. So that is the velocity of the sprint. B asked, what is the average velocity of his walk back to the starting line? Well, when he walks back to the starting line, to get his average velocity, you have to go change in position over time again. Our time is 40 seconds. It gave us that. Our change in position, we have to think. Our final position is back at the starting line. So that's the 0 meter mark again. We came back to our origin. So you subtract that from the initial position, which was 50 meters down the track. So 0 minus 50 meters is negative 50. So negative 50 meters divided by 40 seconds, the time it took him to walk, will give you a negative 1.25 meters per second. So even though he was walking in the negative direction, so that makes his velocity negative. So the velocity is negative 1.25 meters per second. Now the next question asks, C, the average velocity for the complete round trip. Here's where it can get a little tricky until you learn it. The average velocity for the complete round trip, 0. How can he have 0 velocity if he sprinted 50 meters in 8 seconds and then walked back to the starting line in 40 seconds? Hold on, Mr. Simmons, he was moving. He can't have 0 velocity, can he? Yes, he can, because remember, velocity average is your total displacement, your change in displacement over the total time. So even if you sprint down the track 50 meters, if you walk back to that original starting point, your total complete displacement was 0. So you started at the starting line, went down 50 meters, walked back to the starting line, 50 meters, you're at that starting point, 0 divided by anything, which would be 48 seconds, because 40 seconds for the walk, 8 seconds for the sprint. 0 divided by 48 is 0. And lastly, average speed for the trip, the total trip, he walked 50 meters down track, 50 meters back, that's 100 meters, divided by the time, which was 40 seconds for the sprint, 40 seconds for the walk, 8 seconds for the sprint, 48 seconds total, so 100 meters divided by 48 seconds would give you 2.08 meters per second for average speed. Because remember, average speed does not take into account your final displacement.